Again, you have to decide what is your risk preference and which investments will you make on day one. Generally, you go into work and the HR department chief will ask you what kind of insurances do you want? Do you want dental care? Do you want eye care? Do you want death and dismemberment? Do you want long-term care, short-term disability? And then also, what kind of stocks do you want to invest in our 401k plan? You need to make that choice on day one. And I know when I went to work in 5 different industries, I was asked that at 8 a.m. or 9 a.m., and they wanted to know my choices by noon and not to change them for 6 months because they don't want you going in and out of those investments very rapidly. So you need to make your mind up. What is your risk preference and which things do you want to invest in? And now you know what the total average returns are on those instruments. So you make your choices. Do you want a high risk, high return investment? Or do you want something lower risk? Maybe you can invest in a money market or a T-bill mutual fund in your company's portfolio of offerings. Here we can take all the returns that are listed in our textbook and plot them. And when you plot them, you come up with something called a histogram. And basically it's also called a frequency distribution. If you have a ton of different returns, you'll see what looks like a normal distribution. Here's an example of a middle school, Polk Middle School, 6th grade students looking at the SCAT scores, school and college ability test for 6th graders, and then how many fall within 501 and 600. And you just count them. You count the number of data points, and we see that 40 people scored between a 501 and a 600 on the SCAT test. So these are called frequency distributions. The more data points you have, the more normal it will look. And you can do all kinds of statistics on it. Then you can calculate the mean, the mode, the median, the variance, the standard deviation, and make some assumptions about, in the case of stock returns, future returns. So sigma squared is known as the variance. That's the average square difference between the actual return and the average return, and I divide by t minus 1 observations if I have a small sample size. Standard deviation is simply the square root of the sigma squared, or square root of the variance, and that is very simply the square root of the variance up above, and you come up with the below equation. So just take the square root of that variance, and you get the standard deviation, and from those numbers you can make some other observations about future returns. The greater the variance, the higher the standard deviation, the greater the volatility. So you would expect small company stocks to have very high variance and a very high standard deviation compared to, let's say, large company stocks or T-bills. T-bills you'd expect to have a tiny variance, tiny standard deviation. High volatility increases chances that any year's return in the future that will be far different from the average. That's the value in calculating these two measures. These are measures of volatility. So you can see in the T-bill case, not a whole lot of volatility. Everything is above the line. Even though it peaked in 1981, all the returns have been positive, so very small variance, very small standard deviation with T-bills. But again, not real high numbers compared to some of the other instruments. Small company stocks have the largest standard deviation, so they're wildly fluctuating. High variance, high standard deviation, not consistent returns every year, and high variability going off into the future. Let's go through an example of calculating the variance and standard deviation. It's very simple. So these are all posted in terms of percentage, minus 20% for SuperTech, 50%, 30%, and 10%. I can calculate the variance using a 5-step process, which has 6 steps. And the first thing I do is change all these returns into decimals, work with decimals. So minus 0.2, 0.5, 0.3, 0.1 is step 0 of this 6-step process, of which there are 5 steps, 5 remaining steps. What are the average returns? How do I calculate the variance and standard deviation? And what kind of assumptions can I make about future returns once I have them? And which of these two stocks is more volatile? Whichever has the higher variance, higher standard deviation. So the first thing I do is calculate the average. So I sum up the results, minus 0.2, plus 0.5, plus 0.3, plus 0.1, and divide by 4 observations. For SuperTech, for hyperdrive, I do the same thing. Sum up the hyperdrive returns and divide by 4 again. So a very small number of observations. So you can see what I'm doing there, adding up all the returns and then dividing by 4 to get the average. First thing I need to do, step 1, is calculate the average, and there's how you do it. So SuperTech average is 0.175, hyperdrive is 0.055. So very simple to do. Next, I look to calculate the variance, and then I look to calculate standard deviation by taking the square root of the variance. So step 1, convert all the returns to decimal. And we've done that. Add them up and I get 0.7. I divide 0.7 by 4 observations and I get 0.175 for SuperTech. After that, I calculate the deviation. Now, deviation is very simple. I take the actual minus the average. Watch your sign. Minus 0.2 minus 0.175 average equals minus 0.375, and on down the line. Just watch your sign as you're taking and calculating those deviations. Here's a good stopping point and checkpoint, because all your deviations should add up to 0, and you see that they do. So stop. If they do not add up to 0, go back and recalculate the average and then resubtract the numbers till you get 0 deviation. So that's a good checkpoint. Step 4, square them up and add them up. So take minus 0.375 and square it, 0.325 and square it, and add up all those 5, 6, 7, 8-digit numbers and sum the square deviations, get 0.267500. And then finally, I divide that by t minus 1 observations, or 4 minus 1, or 3. So 0.267500 divided by 3 gives me a variance of 0.0892. And then the standard deviation is very simple. It's just the square root of 0.0892, and I get 0.2987, or 29.87%, the very high standard deviation. So that tells you something. That tells you that it's a highly volatile stock. Looking at hyperdrive, I go through the same processes, and I see that their variance is 0.0176. And their standard deviation is 0.1327, or 13.27%, which investment is more volatile. Obviously, SuperTech is much more volatile. You would expect higher returns on average going into the future. Now, what's the advantage of calculating these standard deviations? With a normal distribution, I know that plus or minus 1 standard deviation from the mean, I can make an assumption about future returns if I have a normal, symmetric, fairly bell-shaped frequency distribution. If the more data points I have, the more normal frequency distributions tend to look. So plus or minus 1 standard deviation from the mean. 2/3 of all future returns will fall within that band. I also know that plus or minus 2 standard deviations from the mean, 95% of future returns will fall within that. And then plus or minus 3 standard deviations from the average, 99% of future returns will fall within that band. So you can learn a lot by taking finding the average return for your instrument, and then finding the variance and standard deviation. On average, some lessons we need to learn about stocks and bonds and investments. If I bear risk, it should be highly rewarded. In a given year, there's a significant chance of a dramatic change in value if it's a very risky investment. So be very careful and know the risk premium of all your investments before you invest.